Hey everybody. So today we're going to talk a bit about droughts and El Nino events. So essentially, we're looking at situations where the weather changes and there's either more precipitation or rainfall than normal or less precipitation or rainfall than normal. So droughts are less precipitation than normal, and El Nino events are usually more precipitation than normal. So for civilization, this can have drastic effects, especially when we're talking about agricultural peoples. When we're talking about foragers and hunter-gatherers. Usually they're mobile, they can move around. Droughts are bad, but they can go other places. But agriculture is an investment in a place, and intensive agriculture is a high investment. So it's harder for people to move and such. And droughts, which are too little rain again, can cause huge stresses on food supplies and stability of complex civilizations. In contrast, in arid environments where there is too much rain, there can be a lot of issues that are caused as well. So there can be issues with erosion, with destruction by flooding and such, in areas where there is a desert climate. And some of these areas with desert climates are quite conducive to complex civilization. So I'm talking specifically about areas where there are rivers that bring water from elsewhere through deserts. These are some of the most fertile areas. These are where some of the largest scale civilizations have been formed. But a lot of the infrastructure, a lot of the places where people live in these desert environments are quite vulnerable to high amounts of rain because there's not the plant cover, there's not the environment essentially to efficiently absorb that water when it rains and keep things like erosion and large scale flooding at bay. So both shifts in too much or too little water from the norm have catastrophic effects on ancient peoples and civilizations. And we'll look at examples where droughts and El Nino events may have played a role in the collapses of civilization among the Maya, among the Puebloans of Chaco Canyon, and among the Moche of Peru as well. So I'm not a meteorologist, but one thing that we should understand in order to really get what's going on with droughts and with El Nino events are some of the basic principles of weather. So here on the slide again, there's the precipitation events we'll be talking about, droughts and El Ninos. So we're going to talk a little basic meteorology, and I'm going to do my best. I'm not perfectly versed in all this, but I'll do my best to explain it so that it's understandable for you. Now, one of the most basic things to keep in mind when we're talking about meteorology and weather, or essentially why temperatures and why conditions like precipitation are the way they are in specific places, is that the Earth is constantly in interaction with the sun and solar radiation or heat. Now, the effects of that solar radiation are going to vary quite a bit based on a number of things. So, how close are you to the equator? What is the angle of that heat or the sunlight to you? So the closer you are to the equator, the more direct overhead the sun is, and the more intense that heat is. While if you're closer to the poles, it's more at an angle and it's less intense. And we also have other things like albedo effects and different absorption of heat based on materials, which are going to affect how hot or cold specific places are, and specifically how hot and cold is the air and the water around those specific places. Now, when we think about hot and cold, another important thing to realize is that this is unequal around the globe. So there's some places that are hotter, there's some places that are colder, but all systems on Earth, whether it be biological or chemical or whatever else, they tend to want to seek an equilibrium. And what that means is temperatures or the amount of salt in water or whatever else, it tends to want to equal out. So uh, if it's like if you take out a glass of water and you put some ice in it, is that water going to stay cold forever with the ice? No, it's not. It's going to the ice is going to melt, which is going to temporarily cool your water some. But eventually, if you leave that glass long enough, it's going to achieve the same temperature as the room. Vice versa, if you take a hot beverage into a cold room, it's going to condense on the cup and do all of these things. But if you leave it long enough, it's going to get to that same temperature. So essentially, it's important to remember when we're talking about weather, there are hot places in the world, there are cold places on the world, but this is unequal. But at the same time, the air and the water that are over those hot and cold places, they tend to push towards an equilibrium. And a gradient is when two areas come into contact with one another and energy moves in one direction or another in order to so that those areas become more equal in temperature or in chemical composition or whatever else. So yeah, and really gradients and this move towards equilibrium is what explains a lot of the movement of weather in the world. And yeah, so as I was saying, there are things like albedo, water currents, and proximity to water. All of these things have make things hotter or cooler. But at the same time, these systems want to find some equilibrium. And when we're talking about heat specifically, but also water, we have another variable, which is pressure. And essentially, the hotter air is, and the hotter water is as well, the more molecules move around in it and bump into one another, creating energy and more heat, and the heavier that air or that water is. Now, we think about air as weightless. That's kind of how we interact with it, but it's really not. And you can see this especially with water. Water is a similar sort of has similar rules to air. If you go down deeper, you're swimming in a pool, you go down deeper in the pool, you're gonna feel that change in pressure in your ears, and you're gonna feel that in your body in a sense, because there's actually greater weight that's falling on you. And so a basic principle with pressure is that the closer you are to the surface or the of the earth, or the deeper you are underwater, even the more pressure there is. The heavier it is, the denser particles are, the more they move around. And vice versa, if you're higher up, air tends to be less dense. Water tends to you tend to be less dense as well. There's less movement. Now, with these gradients and all of this, again, remember, there's different amounts of energy being input, absorbing off or bouncing off the earth and being absorbed. And so there are different levels of air pressure. So all air pressure close to the surface is going to be relatively high. But based on those factors of fluctuating solar radiation, absorption, and all of that, there are going to be some areas of the earth that have lower pressure close to the surface relative to others that have higher pressure. And this interaction of high and low pressure air wanting to come to a gradient is really what explains a lot of weather and how weather moves. And when you're looking at the weather forecast and you see the map, you see these highs and these high and low areas. Those are areas of relatively high or relatively low pressure, and they interact with one another in specific ways. And there are ways that air moves in each of them that are somewhat different as well. So high pressure air, it tends to be warmer and heavier, and so it tends to move down in circulation. And when we talk about high pressure fronts with weather, these are areas that tend to, air is coming from up in the atmosphere. It's hot. They tend to be, when we're in a high pressure zone, there tends to be clear weather and it tends to be hotter. So you have all this air that's moving from high in the atmosphere down because it's heavy. It's bringing that heat and that energy with it towards the surface, and that tends to create hotter temperatures, less weather. Conversely, lighter air, lower pressure, lighter air tends to go up, and it tends to bring things that are close to the surface with it up. So when we talk about low pressure areas, these are areas that tend to have more clouds. They tend to have more rain and weather and such. And but again, remember, with all of these highs and lows, they interact with one another. They're looking for equilibrium. And when these interactions occur is when we tend to see the greatest shifts in weather, the greatest windiness, the greatest precipitation as well. And this essentially this movement, or these gradients of hotter and cooler air and water, higher and lower pressure air and water, they explain the movement of weather and the movement of temperatures. And the most basic form we see for these are vertical kind of circles. So we tend to see this air getting heated up and we tend to see cold air that wants to go up into the atmosphere. It can get heated up, it can drop, and it creates these circular movements. The same thing with water. We tend to see, and this can be vertical, but this can also be horizontal on the map. So there are movements of water and air from areas that are cooler to hotter, and vice versa, based on these rules of pressure and these rules of heat. And we're talking about circulation. This is essentially how air and water moves. And wind is the product of these different density, different pressure airs moving around. Ocean currents are quite similar to wind as well. And we have these major air and these major ocean currents that move things all over the globe. And the nature of whether they're moving one way or another has to do with differences in heat and such over land masses versus over water. We have prevailing winds and prevailing currents. The prevailing winds can change based on the seasons and how much heat is hitting a given spot in any given season. But there are some fairly normal patterns of wind that we see. Some winds moving cold air into warmer regions, and some winds moving warm air into colder regions. Similarly, we have ocean currents that do the same things in prevailing ocean currents. And there are some really important and interesting effects in terms of temperature and precipitation with ocean currents. We'll get to a little more as we talk about El Niños. But there are currents of water that come from the north. They move cold water up towards the surface and further south, and it gets heated up, and it eventually loops back towards the north. And we have currents from the south that go north, bringing warm water up along a coast. Now, shifts in solar radiation, in climate, and these larger factors that we've already talked about, they can change prevailing wind currents and prevailing air currents. And things ranging from volcanic eruptions that we talked about last week to shifts in the solidity of the ocean. All kinds of things can shift these prevailing weather patterns. And what really causes droughts and El Ninos are shifts in these prevailing patterns. Is it overall cooler or warmer? Does that affect the plant cover on land? Does that in turn affect how much how things are absorbed or not? All of these can change the movement of air and water and where things like moisture and precipitation are being carried. Now, when we're talking about rainfall and precipitation, the thing to remember is this air is constantly moving around, and so it's moving over both heated and cooled surfaces. So some types of environments that absorb a lot of solar radiation are going to be hotter, and that's going to heat up the air. Other areas are going like water, for example, are going to be cooler. That's naturally going to bring air down, absorb energy and cool it off. Precipitation really results by moisture in these hot and cool surfaces being picked up by these air currents. And when we talk about moisture in these air currents, we're talking about humidity, how much water vapor or how much moisture is in the air. So when air moves over bodies of water or moves over areas with a lot of plant cover, it can pick up a lot of moisture, which is humidity. And of course, we feel that here, especially a lot of the most humid times here is when we have prevailing currents of air coming from the Gulf into Louisiana. So we have these moist airs that are flowing, or this moist air that's flowing from the Gulf north into our area, and we feel this humidity where things are sticky and wet. You have issues sweating and all of this. Now, with lows, when there's relatively low pressure, that moist air is picked up and it is brought into the atmosphere. And essentially, with these lows, that moisture is brought into the atmosphere, and when there's enough of it, when it's high enough up, the gases, so the gases, water vapor, they cool, they condense, and they become first clouds, and then they become precipitation. Now, when things are not so cold in that area where precipitation forms, we have rain. But when in colder parts of the world during the winters, you will get other forms of precipitation like snow. That's just because that moisture in the air is very rapidly cooled and it falls as semi-solids or solids. So things like snow, sleet, or hail are these cooler forms of rain. Again, remember, it's these movements of air. So air is moving around these gradients. They move over landforms or they move over water. They pick up moisture in lows. That moisture goes up into the atmosphere where it cools down the gas, that's water vapor, solidifies. You get clouds, you get rainfall. Now, where rain happens really is affected by something called adiabatic processes. So, and this has to do with the interaction of these currents of air with landforms. So, and with the surface of the earth generally. So, as air moves over flat areas, again, if it's a low, it goes up, you get rain. If it's a high, the air is falling, you don't necessarily have as much moisture. You're not getting the moisture from the highs, you're not getting, and you're not getting these processes where rain form. Of course, when a high pressure and a low pressure front move, there's a interaction between this heavier rising, this heavier air and this lighter air. So, and this frontier causes air to rapidly rise and tends to cause more violent precipitation, more violent weather patterns. So, usually things like hurricanes, they happen on fronts between highs and lows. That's where these storms are stared, or where they stare in between highs and lows. And but in addition to these fronts where these different temperature airs meet, air also interacts with landforms. And so one classic adiabatic process that explains why some areas have a lot of rain and others is when weather systems come into contact with mountains. So when a weather system comes into contact with mountains, when there's moist air, that moisture gets trapped on one side of the mountain, especially on the windward side of the mountain. And as the air rises up along the mountain and gets cooler, precipitation forms on the windward side of the mountain. And by the time all that air gets over to the other side, or the leeward side of the mountain, usually there's very little moisture left. So usually what we see with big mountain ranges is we have a lusher, wetter side, which is often on the windward side, and a drier, cooler side, which is on the leeward side. You can see this in macro and micro ways, but great examples of these, for example, are looking at major mountain ranges like the Andes. So on one side of the Andes in South America, you have a tropical rainforest. So this moist air going over the jungle, coming from the ocean, it hits up against the mountains. All that rain is wrung out essentially most of it before it crosses the Andes. And then on the other side of the Andes, especially in the central and southern Andes, it's very dry. There's very little rain normally. A similar thing happens also with the Himalayas, where there's a lot of moisture near the Indian subcontinent on one side of the Himalayas, and there's very little into the Tibetan Plateau and Nepal and all of that once you get past Nepal, because it's going through these same adiabatic processes. So air currents, they interact with landforms and cause rain due to interaction with mountains, due to pushing up against different air currents and interacting with these different air currents, and due to interacting with lush vegetated areas versus drier areas. So another thing to point out is that vegetated areas tend to have greater humidity and moisture because plants are giving off water vapor. They're giving off water as part of their processes of growth and life processes, essentially. So they take up water through their roots, they use it, and then excess water is given off through transpiration. So there tends to be more moisture in vegetated areas and less moisture in non-vegetated areas. And what happens when we have extreme droughts and the land becomes parched and dry, this can lead to further aridification and further and less precipitation ultimately. If there's no moisture left in the earth, if plants die and things like that, it'll be harder for rain to come back. Now, when we talk about currents specific of water specifically, it's interesting because colder water tends to absorb heat, which in turn causes drier air to occur near it. So you'll see drier, cooler air around cold water currents. So some famous cold water currents are the Humboldt current that goes by Peru and South America, Chile. It's a cold water current, and along the coast, because this heat, this air is being absorbed, the air tends to be drier, tends to be more desert-like. A similar area to point out here in the US is looking at Southern California, looking at Mexico, coastal Pacific Mexico as well. And these cold water currents, they tend to moderate temperatures as well. So it doesn't get quite as hot because this heat is being absorbed, and it tends to be kind of cooler and more Mediterranean or desert-like. Now, hot water currents, they tend to raise temperatures to a degree, and they tend to promote more moisture. So an example of a famous hot water current is the Gulf Stream. The Gulf Stream creates significantly hotter temperature and creates quite moist and verdant conditions in Europe. So we have areas in Europe that have the same latitudes as Canada, and they have pretty nice weather. So I lived in the Netherlands, for example. The Netherlands is up, in central Canada in terms of latitudes. It was an area, it's close to the sea where I lived. And what I felt was that the weather was never super, super hot. It got a little hot in the summer, but it was never super cold either. It was always just kind of like raw and like a little chilly. You'd have occasional snow and ice. It didn't happen when I was there, but all of this is thanks to these warm water currents and being close to them. And the Netherlands and Great Britain and lots of Europe is quite verdant because you have this, the air moves over that water, absorbs, and it actually gives off heat, and with it gives off water vapor, which goes up into the atmosphere, and you get rain. Now, we have prevailing weather systems based on these water currents and air currents and such. And the red essentially here is where it's very dry. The blue is where it's very wet. Now, droughts are caused by things like shifts in global climate that cause changes in currents of water and air. They can also be short-term things like volcanic eruptions, which can create changes in weather over years or decades, can cause cooling often. And things like the melting of glaciers and such, differences in absorption, all these macro things can cause shorter term or longer, more persistent shifts. And what we're seeing, like in the West, in the US, for example, is we're probably seeing longer term shifts caused by climate change and precipitation models and weather as things become hotter. Now, deforestation and man-made deforestation in particular, as well as the building of cities and such that absorb a lot more heat, they can cause a permanent or they can cause significant shifts in precipitation and weather patterns as well. So that's something to think about. Now, one of the most famous regular shifts in weather is the El Nino Southern Oscillation event, where we go between El Ninos and La Ninas. You've probably heard of these. And essentially, this is a major shift in Pacific currents where the direction of a major current, the Walker circulation, periodically changes. So during normal conditions and La Nina conditions, we have these cold water currents coming from the Arctic along South America, with the major current moving east towards Australia and such, and heating up. But during El Nino years, the direction of there are shifts in winds, there's shifts in water currents that actually move a lot of that warm water around the equator. Instead of it going east, it shifts to the west, and it intersects with the more stable cold water currents coming from Peru, and it has a major effect on the weather, and it causes places, so both El Nino and La Nina, it causes places that are normally arid to have rain, and it causes places that are normally wet to be drier, and this can have major negative consequences. So El Ninos can be felt throughout the Americas and also in Asia as well. I remember when I was working in Honduras in 2015, doing a major bout of field work. This was during an El Nino year, and there's a normal cycle of rains in Honduras where during the summer, it's the rainy season, it's wet. That summer, there was very little rain. There were drought conditions. And I remember the water in the towns I was working even would be off for like 2 weeks at a time in order to conserve water. You'd have these big cisterns and tanks. That's what people do there, essentially. But there were negative effects because of that in terms of agriculture. It was uncomfortable for us. It was hotter, and yuckier. Of course, when we talk about the US, we also talk a lot about El Niños and La Niñas, and this causes shifts in precipitation throughout the US as well. So during La Nina patterns here in Louisiana, for example, it tends to be drier. So this year is a La Nina year. We have drier than normal weather in the summer. And this tends to be seen in the Southwest as well. So La Ninas are not good for the Southwest, but there are areas like the Pacific Northwest and the Midwest that are cooler. In contrast, during El Niños, we tend to have colder and wetter situations here in Louisiana. There are warmer and drier situations further north. Now, where El Nino and La Nina affect us the most has to do with hurricane activity. And we see shifts in wind patterns due to El Nino and La Nina, where during La Nina, we tend to have more hurricanes because of these shifts in prevailing winds that make conditions that are more, that help hurricanes to form. And during El Niños, we have less hurricanes. This is the opposite in the Pacific. They have more hurricanes during El Nino and less during La Nina. So how do we study droughts and weather fluctuations in the past? There are a number of great indices depending on where you are. You can use ice cores to look at shifts in precipitation. You can also use other indices like tree rings. So with ice cores, we can look at the prevalence of oxygen isotopes. Typically, when there are when there's an increased ratio of oxygen 18, which is an unstable isotope, to oxygen 16, there's greater evaporation, which suggests lower precipitation. So there's more water that's evaporating off bodies of water because it's hotter, and vice versa. We can see this in ice cores. We can also see this in sediment cores from lakes. We can also use tree rings. So trees record precipitation annually. Basically, we can look at the width of a tree ring, and these are deciduous trees that are occurring in areas that have seasonality, so areas that have winters and summers. And in these areas, the trees grow essentially in discrete events. The more growth they have, typically the wetter conditions are, the less growth they have, the drier. So thinner tree rings usually correlate with drier conditions, while thicker ones correlate with weather. Now, what's really cool about tree rings is we do have examples of lumber that's even thousands of years old, and we can overlap tree rings. And so in certain areas of the world, we have these climatological records that have a precision year over year that go back as much as 4,000 years. We can also use sediment cores and look at oxygen isotopes. We can also look at minerals in these sediment cores to look at the deposition of material year over year and the relative amount of oxygen isotopes and such. We collect sediment cores from lakes, most typically. So things fall at a constant rate. Different things fall in the lake at different times. So we have this laminated effect where you can see all these little lines. And you can carbon date these different levels and reconstruct the vegetation, but also reconstruct the climate with things like oxygen isotopes. You can also, in caves and in some cases in soil, you can look at gypsum. So gypsum is a mineral that crystallizes at different rates depending on moisture and evaporation. And you can look at the relative amount of gypsum at different points and reconstruct climates. Now, there are issues with all of these proxies. So some of these are more chronologically precise than others. So things like tree rings are very precise. But when we're talking about using carbon dating, we're going to have plus or minus 15 years or 50 years or 25 years or so. And they're less precise. And when we're talking about mineralogical dating, so there are other ways to date minerals, there may be an even greater gap. So how precise is this chronologically? How well can that tell us about when climate changes or changes in precipitation are happening? Also, how local or global are the effects? So some things like ice cores might be better at showing us more global shifts in temperatures, though there are limits to that even. So we're not going to expect ice cores from the North Pole to tell us what's happening in the Southern Hemisphere or far, far away from those places. Um, while things like tree rings are going to be very local, they're not going to tell us about what was happening maybe even 2 valleys over. And so these are all limitations and things to think about when we're considering proxies. And not all of these occur. So there's some areas where we might not find lakes where we can find sediment cores. There are tropical areas where we don't have deciduous wood or wood rots easily. So there are limitations to all of these, but we can use them all to reconstruct climates in different ways. Now, getting to our case studies and this question. So how do civilizations respond to drought and El Nino events? The first group I want to talk about a little bit is one that I know the best, the ancient Maya. So I'm a Mayanist. I work in Honduras. I think I mentioned that in the intro lecture. But the Maya are famous because people debate whether or not droughts caused the collapse of Maya civilization. Now, the argument that I'll make to you is it's probably one of multiple factors, and it's not that simple in any case to say that, and we talked about this with volcanism as well. It's not that simple to say that any one natural factor alone is responsible for the collapse of society. Often it's about how do people respond to these challenges? How great are these challenges? What else is going on? But climate changes and droughts, as well as El Nino events, they do cause stresses on complex societies, which can contribute to collapse. Now, when we talk about the Maya, we're talking about an ancient Mesoamerican people. Mesoamerica is the area that's made up of modern parts of modern-day Mexico and Central America. Specifically in Central America, the countries of Guatemala, Belize, Honduras, and El Salvador, even into Nicaragua a little bit, but not so much. And the Maya, they lived in this green area, so the Yucatan Peninsula, a lot of Guatemala, and parts of El Salvador and Honduras. The Maya, they're famous during their apogee, during the Classic period. This is what we're going to talk about. So the Classic period is 8200 to 900. They're famous for making these large tropical cities that have pyramids, ball courts, and public works. So they have roads called sape, they have reservoirs in some cases. This was a complex civilization, and some of the largest cities may have had more than 100,000 people at their apogees. They're famous for developing the most advanced writing system in the Americas, Maya hieroglyphics. This is a phonetic writing system, so it makes consonant vowel clusters. So instead of A, B, C, D, the Maya would say things like bo, ba, boo, ko, ka, ku, so on and so on. And this is a writing system where you're capable of expressing any idea or thought in the spoken language because it's phonetic. They were an unequal society. It was a society where there were a few nobles and warriors and kings. So there were kings called the House that ruled over the ancient Maya cities. Each city typically had its own ruler. So we talk about city-states or unstable, even regional polities for short periods of time. And the wealthy, the powerful, they lived in much nicer houses and had better food and greater riches than the average Maya, who were often farmers. The Maya collapse, the most famous collapse, at least that we talk about, occurs in a period called the Terminal Classic from 800 to 900. And a lot of people have argued that drought may have been a major contributor to the Maya collapse. And this is because if we look at this precipitate, these are from lake cores. So these are sediment cores from lake cores in Guatemala. We see a major period of drought. So a relatively drier conditions around 800 to 900 and afterwards even. And when we look at this period of drought, it corresponds with a decrease in the number of cities, a decrease in the number of monuments and such. So people have argued that this period from 800 to 900, you can see this major sort of dip in precipitation there, um, may have corresponded with the collapse, or may have been a cause of the collapse of Maya society. And these wetter and drier conditions, they're based on the ratio of oxygen 18 to oxygen 16 isotopes that I was saying. And so there, the drier conditions, there's greater evaporation from the lakes that causes a greater imbalance in this ratio. Now, as a Mayanist, we certainly consider drought as one factor that may have destabilized society, but it's simplistic to suggest that it was the only factor that caused the fall of the Maya. Uh, One of the biggest issues with this is when we talk about the collapse, what do you think about when you think of the word collapse? You think about a sudden event that led to the fall of a political system, simplification of social relations and such. But the collapse for the Maya, it occurred over a more than 100-year period and occurred at different times in different places. We're talking about lots of little collapses, not one big collapse. Now, the other thing about the Maya world is it's quite environmentally diverse. So there are some areas which are more susceptible to problems based on drought. So there may be a lack of rivers. There may be other factors that cause a lack of rainfall to create greater problems. And there are other areas where there are rivers, there's naturally more rainfall and such that are affected differently by these droughts. So droughts are going to be unequally bad problems in different parts of the Maya world. So near where I live in Copan, for example, even in dry times, there's a lot of rainfall still, and there's all these rivers and such. So it would have been much less of an issue there than it would have been in the Yucatan Peninsula, for example. There seems to be different processes going on in different parts of the Maya world related to the collapses of these city-states. So there's clear evidence for warfare in certain areas. So there's a famous site in the Peteshta Batun region of the Maya world. This is a river region in Guatemala. There are sites like Agua Teca and those pilas where we see last-minute fortifications that are put up. We see burning events. We see destruction, ritual, both ritual and actual destruction of buildings. And we see that people are rapidly abandoning these areas and even dead bodies and such. So in another site in this area that there's actually a mass grave in a cistern. And this seems to have happened when the site was destroyed due to warfare. But so is warfare directly related to drought? It can be caused by instability due to drought, but not necessarily. So there's some areas that where it seems like violence led to the end of city-states, but it's not all areas. There are other areas that are abandoned without conflict. So something happened to the social system that led people to vote with their feet and leave these areas. So large cities like Tikal and Caracol, people just seem to have up and left. And the most interesting of all is that this collapse was incomplete in the Yucatan Peninsula in the northern Maya area, which is actually the driest and most drought susceptible part of the whole Maya area. These city-states did not collapse during the terminal classic. Rather, there were places like Chichen Itza and and the Puc sites that continue through this area. There are multiple kingdoms that continue. Now, they seem to have been a little different than during the classic period. This is something regional, as well as there may have been changes, but they never collapse. As I said, these are some of the driest regions. So the idea of a Maya collapse, first of all, there's no one Maya. There were all these different city-states. But the Maya did not completely collapse, and there were Maya city-states with pyramids, with kings, with all this, all the way up until the Spanish conquest, essentially, especially in the Yucatan Peninsula. So it's a misnomer to say that the collapse was complete and that it was caused by drought alone. So what role did drought play then? Personally, I think it was one of many destabilizing factors. Maya kings had an important role to play in agricultural cycles. So they would impersonate the rain god, for example, and played ritual roles in protecting their peoples and making sure that agriculture worked. And so droughts would have caused stress. That stress in some cases may have led to greater warfare. So people going out from their cities and attacking others in order to get limited resources. It may have undermined the legitimacy of some rulers in some places. So some people may have questioned their rulers because they were not providing the rain and they were not providing the support that they claimed that they could give through interceding with the gods. And I think also that this is kind of a cascading system. As one city collapsed, their regional commercial ties, their regional political ties, and this may have destabilized other cities, including in areas that were not directly susceptible to drought in the same ways as others. And so I think it's a mixture of a lot of different factors that led to the Maya collapse, with drought being one of them. May have been a feature that led to these cascading events to begin. But ultimately, again, a question is, how do societies react? How do they respond to environmental changes and stresses? What do leaders do? These are questions to ask that help determine whether or not societies collapse or continue. A second example I'll give you of droughts causing collapse, and I think there's much greater evidence for this, for a local collapse at least, is Chaco Canyon and the Puebloan civilization. Now, Chaco Canyon is located in the Four Corners region in modern-day Colorado, so near the border with New Mexico. It is an arid area, it's a marginal area. Chaco Canyon specifically is a canyon within this area that has that feeds off the local rivers. It has water that is present on the surface and slightly below the surface as well during good times. Chaco Canyon is famous for its great houses, and these great houses existed from, if I remember correctly, around 8600 to 80, right before 1100. And there's something like 12 of them that are in Chaco Canyon. These are sometimes referred to as apartment blocks. They're masonry compounds with lots of rooms, and they have these circular spaces within them called kivas. These were essentially temples. You still see these today in use to some degree with Puebloan people. They also have plaza spaces. It doesn't seem like they were occupied by huge populations year-round. Rather, people would come and stay in them. They'd leave deposits in them, and a few families would live in these great houses. Chaco Canyon was the epicenter of a regional system that was connected with the roads. The roads are oddly straight. That's something people go back and forth about. So are they practical? Are they ritual? But they connected the great houses of Chaco Canyon to other smaller great houses and other surrounding settlements, as well as resources like wood, which were in the mountains that surround Chaco Canyon. Chaco Canyon was a magnet for imported goods. There were goods that were there from as far away as Mesoamerica. So we have macaw feathers and copper that were brought there. There's even evidence at Chaco Canyon that chocolate, which was grown in Mesoamerica, was consumed, which is really cool. They have shells from the Pacific. They have turquoise from further south in the border between Mexico and the US. It was an area that brought in a lot of exotic goods and brought in a lot of people. There's debates about how complex the peoples of Chaco Canyon were, but it doesn't seem like a lot of people argue there wasn't really institutionalized inequality. There wasn't chiefs and commoners. It was kind of this emergent society where maybe some families had more than others, but individuals at least weren't elevated. There haven't been tombs found with lots of grave goods and such that make us suggest that there were full-time leaders. And the most prominent theory about what Chaco Canyon was and what all these great houses were is that it was a pilgrimage center. It was a place that people came to visit periodically from all over the region, and they'd bring exotic goods with them, and they'd do ceremonies in these kivas or circular spaces that were temples, and they would leave again back to where they lived with a smaller permanent population. This was an area where that was somewhat fertile in good times that farming occurred, and the Pueblans were quite ingenious. They created things like check dams and irrigation canals in order to farm corn in this more arid environment, this marginal environment. So we have evidence of these dams that essentially retain moisture in the soil or direct the flow of water when there's more rain and greater, they're larger flows of water, you can say. And again, there are these outlying smaller great houses and settlements that funnel into Chaco throughout the Four Coroners area. Now, tree ring data shows us that there were major droughts around 81,150 at several points. We actually get these tree rings from the beams that Chaco Canyon was built with, which come from the surrounding mountains. We can see, and we also get the tree rings from the trees themselves. So we can see what the climate is like year by year in this region, which is really cool. And we can tell that there was a period of drought around 1150. There are 3 or 4 years in a row, actually, where there's less precipitation than normal. It's also believed that there's probably overexploitation of wood around. So their pinyon pines are famous around Chaco, but there's overexploitation of wood that can lead to erosion. It can lead to less water being absorbed and more problems. And so it's and what we see is Chaco Canyon is abandoned by AD 1170. So was drought a major factor that led to that abandonment? And in the region, we see an increase in cannibalism and violence. So we see bones with cut marks. We see more violent deaths in the osteo pathologies of individuals buried during this period. And we see the abandonment of these large cities. So what caused the collapse of this society? I think in this case, drought was a major factor. It would have caused it to be more difficult for people to live in the area and people to question social systems and religious systems. Deforestation could have certainly contributed to this, but ultimately what caused society to collapse were people questioning the social order and determining to do other things and move elsewhere. And what I will say about Chaco and Puebloan society is we should consider mass migrations occurring, but not necessarily a complete collapse of social and political systems. And what we see in the Southwest, not just at Chaco elsewhere, is we see migrations from one area to another, often caused by droughts. And there are people that continue a Chacoan, Puebloan lifestyle until today even. So Taos Pueblo is an example of an area where there are kivas and these apartment buildings and such in modern day New Mexico. So the response that Puebloan people had to droughts was often to move. Does that necessarily mean that their society completely collapsed? No, because they moved to other places. So Mesa Verde is a place that rose after Chaco Canyon. It has the same apartment blocks, it has the same kivas and things like that. What makes Chaco Canyon exceptional, of course, is it was the biggest and most developed set of these great houses that was ever built. But it's a tradition that continues. And so we have to think about that when we think of collapse. The final example I have for you are the Moche civilization and El Nino. So this is a case where there's too much rain. So the Moche, they live in northern and central Peru along the coast. And we talk about the Moche from about 200 to 800 AD, more or less. This is a naturally arid area that is cut by these seasonal rivers. So the rivers don't necessarily have flowing water on the surface year round, but they're aquifers. They have water under the surface. And there are a couple that have water that actually flows. Now, the Moche, they're famous for their realistic pottery. They literally depicted just about everything and anything you can think of in pottery. They're portraits of individuals, animals, images of warfare, everyday life, everything. They were sophisticated metal workers, so they are known for working gold, silver, and copper. They created these large adobe pyramids. So I've been these are my pictures. I've been and seen Moche stuff. They don't look that impressive now, but they were really impressive in the past, and they're partially excavated. So these pyramids, they were decorated with stucco murals. You see all kinds of images of society and of individuals, gods, motifs, all of that on the stucco murals. And they're highly unequal societies. So there were kings of the Moche that had opulent tombs. One of the most famous of this is the Lord of Sipan. It's something that I saw in person as well. I think he was buried with 2 tons of metal, and he was buried with 4 people sacrificed around him, attendants. So that to me screams inequality. So human sacrifices in a tomb, that's the ultimate sign of inequality. If you have other people that are killed when you die and are buried with you, you are a high status individual. And we see in the iconography, we see in these tombs, lots of examples of inequality where the Moche were dominated by these kings. It was a warrior martial society. They're warriors that fought among themselves. We have evidence of even sacrifice of warriors even. What supported Moche society, though, was large-scale irrigation in these river valleys with the aquifers. So they would dig irrigation canals through along these rivers and river valleys and divert water to expand their growth of crops. So they were growing things like corn, cotton, specifically in these environments. They were trading for things like potatoes, sweet potatoes, and all that from elsewhere. Let's see. So, but this was a system that was highly based off of agriculture, intensive agriculture in these canals. But El Nino events, where there's greater precipitation than normal, throws a wrench in the works, and it still creates major problems in Peru today. Creates major problems no matter where you are. So because there's not a lot of ground cover most places, when it rains hard and heavy, you have these torrential floods. So in Peru and also in Baja California and Mexico, I've seen similar things where you have essentially these quebradas which are dry river bottoms where water goes through during floods. When it floods, bridges can be destroyed. When it floods, infrastructure can be washed away. Ground cover and vegetation is really important because it helps us to absorb all of that water. And water is going to look for somewhere to go when rain and flooding occurs. We know that with the Moche, there were a couple major El Nino events recorded. One of the most important ones that's associated with one of the first big collapses of some of these city-states happened 560 through 590. A major cycle where there was a lot of rain initially and then droughts afterwards. This may have partially been spurred by the El Nino may have been spurred by decreased temperatures globally due to a major volcanic eruption, the Ilopango eruption that happened in 536. It's hard to say for sure what the interaction between those two are, but we know that the Moche freaked out about it. We know that they took drastic measures. So we actually find a strata at one of the major wakas or temples, and one of the largest ones that existed in the Moche world. There are multiple city-states probably for the Moche too, I'll note that. But this is one called Waka de la Luna. We find a major sacrifice that happens around this time of something like 40 warriors. We see that their hands were tied behind their back. We see a mark on the bones in their on their upper spine, you know, where your throat would be. That suggests that it was a major sacrifice. And what's interesting is they are literally stuck in the mud. They're stuck in this wet settlement. You can tell the nature of the sediment from the excavations. And so it seems like there was a major sacrifice that happened in response to too much rain, all of this rain and flooding and such by the rulers. What was the most drastic effect of all this rain during 560 to 590, though, was that it washed silt and mud and either washed away or filled in all these irrigation canals. These took a lot of labor to maintain and to build, and were the linchpin of this agriculture system that supported lots of people. And they were destroyed probably overnight or over a few days in some cases. And this caused the abandonment of several of the largest Maya or Moche sites. So places like Huaca de la Sol and La Luna, Huaca Colorado. And it's believed that's because people question the social order. Maybe could these rulers protect them? But it didn't necessarily cause the abandonment of all. And we see similar systems rise soon after, upstream often, further upstream. So there are major sites like Galindo, which occurs near Huaca de la Luna de la Sol, where these patterns of Moche society continue. Were they the same rulers and the same exact political order there? It's hard to say for sure. But these patterns continue. We see a smaller El Nino event or another El Nino event happen around 8800. And after that, we tend to talk about the end of the Moche. Now, what I will say is the Moche don't disappear. And there's a weird thing about Peruvian archaeology where they really name the cultures based on pottery styles and material culture. The descendants of the Moche continued, and they created a major empire, the Chimu Empire. And a lot of their material culture is similar, though not identical. So it seems like political systems collapsed and new ones that were based off the old ones continued. So can we say that and so here's a difference between Moche and Chimu pottery to give you the idea that they're related. They're quite related, but there are some differences as well. But again, there's continuity. We can't talk about a complete disappearance of these patterns. We can't talk about that with the Maya. We can't talk about that with the Pueblo either. It's the fall of specific political systems, which are often reconstituted in a new form elsewhere. So what roles does El Nino play in destabilizing Moche society? There's probably widespread destruction of irrigation systems, which may have contributed to the collapse of some of these cities as elites were questioned in their role of maintaining stability in agricultural systems, but not all. So some rulers and some political systems responded better than others. It did not lead to the disappearance of the Moche. There are new centers that are created, and even after the second El Nino in 8800, there's continuity in terms of traditions, language, ideas, and such with groups like the Chimu. So those are the three examples. That's what I have for you today. Have a good night.